electric potential at a point P. Electric potential at a point P. Consider a positive charge plus Q. So it's plus Q. At a point P we are going to find the electric field. The test charge is bring from infinity to the finite point P. So the electric potential at point P is equal to integral minus E dot dr vector from infinity to the finite point R. So here the distance between the source charge and the point P is R. So already we know the electric field E is equal to, due to the point charge, E is equal to 1 by 4 pi epsilon naught Q by R squared R cap. So R cap is a unit vector that points the direction of electric field. So R vector is equal to R cap. So dr vector is equal to dr R cap. So substitute dr vector is equal to dr R cap, as well as electric field E is equal to 1 by 4 by epsilon naught Q by R squared R cap. So taking out minus whatever, so integral infinity to finite distance R. So E is equal to 1 by 4 pi epsilon naught, then Q by R squared R cap dr vector. Then again taking out minus, so minus Q by 4 pi epsilon naught integral from infinity to the finite distance R, then balance 1 by R squared R cap dr vector is equal to R cap dr. So R cap dot R cap, so unit vector dot unit vector is 1. So R dot R is equal to 1. So we are going to differentiate the following. So minus Q by 4 pi epsilon naught integral 1 by R squared dr. So integral x power n dx is equal to x power n plus 1 by n plus 1. So here it's r power minus 2, that is r power minus n. So that is equal to minus r power, so n is equal to minus 2. So minus 2 plus 1 by minus 2 plus 1, you will get minus 1 by minus 1. So minus 1 by r. So lower limit, it's infinity to the finite distance r. So finally minus Q by 4 pi epsilon naught, then 1 by r minus. So from infinity to r. So you need to substitute upper limit minus lower limit. So minus of minus plus, so Q by 4 pi epsilon naught. So instead of r you put r, then minus 1 by infinity. So what's by infinity? Number by 0 is infinity, 0 by 1 is equal to 0. So you need to know these two things. So many derivations we are using that number by 0 is infinity, 0 by number is 0. So Q by 4 pi epsilon naught 1 by r minus 1 by 0. So taking 0 to the top, that is denominator, number into 0 is 0. So you will get finally it's 1 by 4 pi epsilon naught Q by R. So the potential at P is equal to 1 by 4 by epsilon naught Q by R. It's for positive charge. So what we had done, they may ask in 3 marks a small derivation. So we are using some mathematics. So we need to know some mathematics to study physics. So consider a charge. We are going to find the electric potential at the point P. So already we use the formula minus E dot dr integral from infinity to the finite distance r. So electric field E equal to 1 by 4 by epsilon naught Q by R squared, and so on. So we are doing some mathematical calculation. Finally we will get, so the potential V is equal to 1 by 4 by epsilon naught Q by R. So what's the difference? What's the difference between charge, it's Q by R. Yeah, fine. Okay students, it's plus 1 by 4 by epsilon naught Q by R. If it is minus, if it is a source charge is minus, you will get minus Q by R. Okay, we'll see some next class. We'll see some important results from the electric potential. Okay students, thank you.